what I'm going to do is, again, this is going to be in terms of a title, graphing polynomials. You can write this down in your composition book. I'm just doing it on this so that the screen can be seen on the video instead of me doing it by hand and having my hands block the way. So you guys are putting this in your composition book. Graphing graphing, start again, polynomials. And I'm going to say not sketching. Okay, so I do want us to be able to sketch it. That's what I'm going to expect you, but I want us to see this so that maybe we understand these better. And we're going to do this using synthetic division. Okay, I'm going to go through two examples. So the first one I'm going to do is we're going to graph P of X or F of X. I'll do P of X because it's a polynomial, is equal to X to the third minus X squared minus 9X plus 9. Now, when I'm trying to just graph, I am not necessarily trying to find my P over Q's and find solutions because I want to graph more than just my solutions. So what I'm going to do is I'm going to do a table of synthetic division to get my points that I'm going to plot. So what I'm going to do is I'm going to try negatives and positives, and I'm going to kind of go in order. Okay. So let's say, for example, I start at a -4. Okay, so I'm going to make a table. I'm going to have 1, -1, -9, 9. And again, let's say I start with a -4 and just kind of see what happens from there. So when I am doing this, I bring down my first number. And then what I'm doing is I'm going to be taking this 1 and multiplying it with -4. I get a -4, so I'm going to get a -5. I'm multiplying -5 times -4, I get a 20. I add it here, I get 11. I have 11 times a -4, that's a -44. I add it and I get a -35. So just so we understand a couple of things. First off, this is a point. This point is -4, -35, which we're not going to fit on our graph. But does anyone notice anything? Anyone notice anything? Okay, it is, yes. Okay, alternating signs. And so, Dylan, what does alternating signs mean? Okay, so right now I know that this is a lower bound. Why? Because of the alternating signs. Okay, alternating signs, positive, negative. So what that means is if I didn't get alternating signs, then maybe I want to try some numbers in front of that because maybe I'm not at the low part of the graph. But in this case, I am. So I haven't missed any zeros. There aren't any zeros in front of -4. Okay, I'm not missing any in my graph. So now I'm going to go in order. -3. And do I do this when I'm finding zeros? No, I would never try a -4 if I was trying to find my zeros because my P is 9, right? Positive -1, positive -3, positive -9. I know 4 is not going to be, or -4 is not going to be a solution, but it's still going to be a point on my graph. Okay, so I bring down my 1. And so we're always bringing down whatever our rate is. So 1 times -3 is -3. I add it to -1, I get a -4. -4 times -3 is a 12. I add it to 9, I get a +3. positive 3 times a negative 3, I get a negative 9. I add, I get a 0. Okay, so right now I just found another point. I was going to do it in a different color so you guys can see. This point is negative 3 comma 0. Okay, so I found a 0. Now, sometimes what I will do is at this point, maybe I will solve and find my other zeros. So I just know what they are. I'm not really concerned with that because that's not my goal. I'm just graphing. But what I'm going to do is at this point, I'm going to come over here and I'm going to go, okay, I found a 0. 1 0 is negative 3. I have a negative 4x plus 3. Is that factorable? Yeah, that's an x minus 1 and an x minus 3. So I actually am going to have a 0 at positive 1 and another 0 at 3. Okay, but I still want to continue with my graph because I'm trying to graph it. Okay, so I'm going to go and see, okay, what happens next? Negative 2. Bring down my 1. 1 times negative 2 is negative 2. I add it, I get a negative 3. Negative 3 times negative 2 is a 6. I add it to negative 9, and I get a negative 3. I end up with a negative 3 times a negative 2, which is a 6. I add it to 9, I get 15. So I have another point here. This point is negative 2 comma 15. That's another point. And I'm just going to continue. Negative 1, bring down my 1. Negative 1 times 1 is a negative 1. I add it. I get a negative 2. Negative 2 times negative 1 is a 2. I add it. I get a negative 7. Negative 7 times negative 1 is a 7. I add it. I get 16. So you see, I'm still on the rise. I'm still on the rise. So this is negative 1 comma 16. Okay, so now if I do my 0, bring down my 1. Well, when I do my 0, I'm going to get this back because 1 times 0, 0, I add it, I get negative 1. Negative 1 times 0, 0, I add it, I get negative 9. Negative 9 times 0 is 0, I add it, I get 9. So your 0, you get that line back. That's why when I start all my problems, I always look at what I have here and go, oh, at 0, I'm at 9. Because when I put 0 here, I get the same thing back. That will be my remainder. My remainder is 9. So I have a point at 0, comma 9. So now I have my 1. Now, at this point, I honestly know my 1, right? I found my 1 right there. I found my 1. My 1 is 0. So I'm going to save us some effort and go, okay, I know that one gave me 0. Why? It was one of those. Okay, it was this one right here. So I know, and I'm just going to do my zeros in a different color. I have 1 comma 0. Again, why? Because of this right here. Now, if I didn't do this, I would have found it right now when I did this synthetic division. Okay, I would have found it. Let me try it too. Bring down my 1. 2 times 1 is 2. I add it to negative 1, I get a 1. 1 times 2 is 2. I add it to negative 9, I get a negative 7. Negative 7 times 2 is a negative 14. I add it to 9, and I get a negative 5. So I have a point at 2, comma, negative 5. So you see up here, I was below at the x-axis, above, 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 back down to the x-axis. Now I'm going below. Okay. Now the next number I'm going to try is a 3. Well, the 3, I already know, right? The 3 is going to be a 0. So I already know this one's going to give me a 0. Because it was right here, 0. Again, you could work it out, but you're going to end up getting a 0. So this is 3 comma 0. So these are my 3 solutions. These are my 3 roots because it's a degree 3. I should have 3 solutions. Now I'm going to do a 4 just to show you what happens. I have my 3 solutions. This one, this one, this one. Now, when I try the next one, if I bring down my 1, 4 times 1 is 4. I add it to -1, I get a 3. 3 times 4 is 12. I add it to -9. I get a 3. 3 times 4 is 12. I add it to 9. I get a 21. So now I have a point at 4, 21. Does anyone notice anything? Okay, not a lower bound, but an upper bound, because I did a positive and all of them are positive. If I try 5 and 6 and 7 and 8, I'm just going to be getting bigger and bigger and bigger numbers. This is going to be going up and up and up and up. So this right here is a upper bound. And again, when I'm looking at both of these situations, okay, I'm looking here at this negative, so I'm trying to get my highlighter. I'm looking here at this -4, and when I do a negative and I get alternating signs, that's a lower bound. If I use a positive number and I get all positives back, that is an upper bound. Now, in this case, we already found them, so we already knew we weren't going to be getting any more zeros. But that's what's happening. So now I'm going to graph this, and I'm only going to graph the points that we can fit on our graph. Okay, I'm going to graph the points we can fit on our graph. And so we need to get from -4 to 4 if we can. We'll see. So let's see. I'm going to move it down here. I'm going to do it down here. So I'm going to just draw in my graph. Okay, I'm just going to move this for a second. Anyone still copying this before I move it? Okay, so I'm just going to get my graph here. Since I'm using this, I might as well actually need to get a line. So I'm going to get not a triangle or square, fine. And I think I need to go up higher than down, right? Let's see. So just making sure I can kind of get up to maybe 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So let's just say I'm okay. So I have this graph. Okay. I'm going to be plotting these points on my graph. So let me just get some points. I think I want to do bigger than that. Okay. So I have -4, -35. I'm not going to fit that. I have -3, 0. So I'm going to go to -3, 0 and put my point. I have -2, 15. So I'm going to go -2, 15, 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15. A -116. So -116 would be here. I'm just plotting the points. So I plotted my -3, 0, -2, 15, -116. My 0 was a 9. My 1 was a 0. My 2 is a -5. My 3 is a 0. And then my 4 was a 21. Maybe you can fit it, maybe not. I think I can. So 16, 16, 17, 18, 19, 20, 21. So we have these points. Again, if you want to see the points, I plotted a -3, 0, -2, 15, -1, 16, 0, 9, 1, 0, 2, -5, 3, 0, 4, 21. And then I'm going to connect. And so let me just zoom in and connect. And so for this, it's going down here, going to come up, going to go through, going to come back down, going to come back up, and going to go through. And that's my graph. Now, when we had that lower bound, this one here that was at -4, -35, you see -4, -35, you see I'm on the down. Anything after that is going to keep going down, 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 down. Don't try -5 and -6 and -7. Now, in this case, I wouldn't have tried those, but maybe I would have tried a -9 because 9 would have been a possibility. -9 is not going to work. Then here, when I ended up at 4 getting my positives, that was an upper bound. You see, I'm going up, 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 up. There are values before that, which also would have been an upper bound, but those were not nice integer ones. Okay, so I just didn't see it. But it's going to keep going up forever and ever and ever and ever and ever. So I wouldn't try anything after 4. Now, in this case, the only thing I would have maybe tried was a 9, and that wouldn't have worked. Does that make sense to us? Okay. Now, I want to do one more situation. And this situation is going to show us where maybe we don't have nice zeros like we had here. And maybe we want to be kind of looking at what's happening with our synthetic division to say, oh, wait, I had a negative and now I have a positive. So somewhere in between there should be a 0. Okay, so I'm going to add on a graph. Okay. So let's say for this one, we have P of X equals X. So I'm doing this on a new page. Okay. P of X equals 2x to the 4th plus 5x to the 3rd minus 3x squared minus 9x plus 1. Now, in this situation, unfortunately, in this case, I might get some fractional answers because my Q is a 2, it's not a 1. So I'm going to have 2 in a denominator, possibly also. My P is just 1, positive negative 1, over positive negative 1 or positive negative 2. But we're not trying to find our zeros, we're trying to sketch a graph. Okay. So let's say that I start with I want to start on the negative side and kind of see if I'm missing a 0. So I'm going to do my synthetic division, make a table. I have 2, I have 5, I have -3, -9, and 1. Making sure it's in descending order, making sure I'm not missing a term. Again, I'm not necessarily finding zeros, I'm trying to just find points. So I'm going to put in -4, just see what happens. I'm going to bring down a 2 because it's a 2 in the front. We don't always bring down a 1. Whatever's a lead, that's what we bring down. Okay, it happens to be a 2. So I bring down a 2. So I go 2 times -4 is -8. I add, I get a -3. -3 times -4 is 12. I add, I get a 9. 9 times -4 is a -36. I add a -36. I get a -45. -45 times 4 is going to be, let's see, 1, what am I going to get? 0, 2, 16, 180, add it here. I end up getting 181. Obviously not something I'm going to graph. Do I need to try -5, -6? Was there a 0 in front of -4? Okay, I see you shaking your head no. Why? Why are you saying that? You're right. What happened when I tried a -4? Okay, it's not going to be an upper bound. It's going to be a lower bound. If I'm using a negative number, we're going to consider it a lower bound. If I used a positive number, we're going to consider it an upper bound. So in this case, the reason that this is going, so let me just jot down this point. This point would have been -4, 181. That would have been this point. But what's happening is this is a lower bound. And why is it a lower bound? Because of what we were talking about before. I have a negative number and I'm alternating signs. Lower bound. Okay. Negative number and I got alternating signs. So definitely didn't miss a 0. Definitely didn't miss a 0. Let's say I try -3. Bring it down. I get a -6. I add, I get a -1. I get a +3 when I multiply. I add, I get a 0. Now, is this -3 going to give me a 0? For sure, no. Why? Because it's not a factor of 1, right? So I know it's not going to give me a 0 as my final answer. 0 times -3 is 0. I add it to -9. I get a -9. -9 times -27. -3 is a 27. And I add it to this and I get a 28. So now I know that I have -3, 28 here. Okay, so I'm going down though. That's a big jump from being at 181 a second ago. So bring down my 2. 2 times -2 is a -4. I add it to this, I get a 1. 1 times -2 is -2. I add it to -3, I get a -5. -5 times -2 is a 10. I add it to -9, I get a 1. 1 times -2 is a -2. I add it, I get a negative, what did I get? A -1, right? Did I mess up? Now, you'll notice that, does anyone notice anything? Notice anything at all? So it almost looks like alternating signs, but you see here how it's not. So what you also want to pay attention to is where I am on the graph. I am at a -2, -1. Where was I at -3? A -3, 28. Do you see how I'm above and now I'm below? This is above the x-axis. This one is below the x-axis. So if at -3 for my x, I'm above, and then all of a sudden at -2, I'm below, what has to happen somewhere between -3 and -2? There's a 0. Okay. It's not going to be necessarily a nice 0, I'm not going to concern myself with it right now, but there is a 0 in between there. Okay, so what this means is there is a 0 between x equal -3 and x equal -2. So for some x between -3 and -2, it's going to cross the x-axis. Okay, how do I see that? Because what I'm noticing, and I'll do it in, I guess that teal that I wrote in, I'm above, I'm below. Different signs. So I'm going to continue. Again, we're not necessarily finding zeros. We're focusing on graphing, but I want us to pay attention to what happens here. So, okay, I'm going to do -1. I'm going to bring down my 2. Now, -1 would be a possible maybe solution. Let's see. I don't know. -1 times 2 is 2. -2. I add it to 5. I get a 3. -1 times 3 is -3. I add it to -3. I get a -6. -6 times -1 is a 6. I add it to -9, I get a -3. And -3 times -3 is 3. I add it to 1 and I get a 4. So now I'm at -1, 4. Anyone have anything to say? Okay, I'm back above. I'm back above the x-axis. Okay, I'm back above. So I'm just going to use a different color. So here and here, I was below and now I'm above. I was below and now I'm above. So I actually have another situation here where I have another 0. This time between x equal -2 and x equal -1. So I have 2 zeros, one somewhere here and one somewhere here. Now, none of my possible solutions, because my possible solutions would have been a positive -1 or a positive -1/2, basically. None of those are in between -2 and -1. So it's not it's a real one, but not a rational one. It's like a square root probably, okay? Same thing here. This one would be a square root. It's a real solution. It's just not rational. And not because I'm not seeing it, but because I know what my P's and Q's are. There's nothing that would have been above or below 1 in terms of what I would have tried. Okay, so now let's try 0. Now, again, when I do 0, I get what I have originally because I'm just every time adding 0. So I'm going to get 2, 5, -3, -9, and a 1. Okay. Okay, so let's try a 1. Bring down my 2. Now, 2 times 1 is 2. I add it to 5. I get a 7. 7 times 1 is 7. I add it to -3. I get a 4. 4 times -1. 4 times 1 is a 4. I add it to -9. I get a -5. -5 times 1 is a -5. I add it. I get a -4. Notice anything? I'm just going to change this. I'm going to try to color code with my thing. So, oops. Is this an upper bound? If I have a positive that I'm trying and it's an upper bound, all of these need to be positive. So it's not an upper bound. Huh? I have another 0 though. Have another 0 here. Why do I have another 0? Because again, I was above And now I'm below. So again, I'm here at 0, 1 and 1, -4. Again, this time I am above X axis. And here I am below X axis, which means that somewhere in between these two, I have a 0. So I know I'm going to have a 0 between X equals 0 and X equal 1. Now, maybe that's a 1/2, could be a 1/2. Okay, I could try it, but I'm not actually looking for them. I just want to sketch the graph, but 1/2 could maybe work, and it might, and it's in between, maybe that would work. So let's try 2 and see what happens with 2. Okay, so far I have 1, 2, 3 zeros. Okay, I have 3 zeros here. So let's say I try 2, because I need 4 zeros because it's degree 4. So I bring down my 2. 2 times 2 is 4. I add it to 5. I get 9. 9 times 2 is 18. I add it. I get a 15. 15 times 2 is 30. I add it here. I get a 21. 21 times 2 is 42. I add it. I get a 43. What's true about this? What's true about this right here? Upper bound. Upper bound. Because I used a positive and I got only positives. Gosh darn, so I can't try anything after and get a 0. I only have 3 zeros. Does anyone notice anything? I just write my point out. So this point is 2, 43. So I was above, below. Here, there was a 0. I was below, and then above, 0. I was above, okay? I was above, below, 0. I'm below, above, another 0. Because I was below at -4, and now all of a sudden I'm up at 43. So again, in this case, I have another 0 because again, I am above the X axis. And choose a different color. And so between this and this, I am going to have a 0. This time it's going to be between X equal 1 and X equal 2. Now, between 1 and 2, I don't have any choices between 1 and 2. So this is not going to be nice. Between -2 and -1, that wasn't any of my choices. That would not have been nice. This would not have been nice. Maybe between 0 and 1, maybe a half works. Sometimes you don't get nice answers. So then we're just going to sketch this so we can see what the graph looks like. Okay. So I'm going to draw my graph. Let me just get my. I'm going to do this. Okay. So I'm not going to plot -4, 128, -328. Maybe you can fit it. I guess maybe I could drop this down a little bit, but I do need to get down to a -4. Okay, so I want to at least get down to a -4. So let's see. I don't know if you can fit -3, 28, don't. Do. If you can't, oh well, we won't fit it in. So -3, 1, 2, 3. I'm just putting this mark so I can move my paper. So that's 20, 21, 22, 23, 24, 25, 26, 27, 28. Way up here. If you can't fit it, don't fit it. Don't worry. What you need to know is that if we can't fit it, when we fit the ones we have, we should be going up. We should be going up on that side of -3. So I did -28. If you can't fit it, don't worry about it. Now I'm going to plot -2, -1, which we should all be able to fit. -2, -1. -1, 4. -1, 1, 2, 3, 4. 0, 1. 1, -4. And my 2 is 43. I don't think I can get up to 43. Yeah, yes, you may. So what we want to understand is, seeing this, we need to understand that what's happening in front of this -3, I'm going up forever. To the left of -3. To the right of this, I'm going to go up forever. Okay. So you want to pay attention to that so you understand the flow of the graph. Okay. So again, I was able to fit in my 28, but a lot of us may not have been able to. So I'm just going to take mine off, pretend I can fit it on. What I do know is that the graph had to be going up here. Make it a little thicker. It had to be going up here, coming through. Okay. Then it's going to end up coming here, coming back down. And then here, what happens? Well, we know it ended up going through again, because we know we ended up with my 2 being a 43. So we ended up with this type of a shape. So again, this upper bound 2, at 2, I'm up at 43. So it's going to keep going. If I try 3, anything else, it's going to keep going. So anytime you have a positive that you try and you get no negatives here, this is going to be an upper bound. If we start with, if we have a negative and we get alternating, that's going to be a lower bound. Now, in this case, the lower bound is going up. Okay, but it's on the lower, we call it lower because on the negative side. Okay. So do I expect you guys to be able to necessarily do this? Am I going to ask you to do this? No, I want you to understand that when we do the synthetic division, we actually are getting points. The number we start with in our little box or in our table on the one side is your X. What your remainder is, which is your last number, that's your Y. And these are points. Okay. And when we're doing our synthetic division, especially on problems where you have a lot of things to try and you're going, gosh, am I missing something? Look to see if you have a situation like this and you had choices in front of -4, don't try them. You had a lower bound. If you had a lot of choices, let's say we had like 48 as our P, and I saw at -4, hey, I'm at -181. I don't want to try -6 and -8 and any of those, -12. Wasting my time. Or I don't want to try anything after 2. So if it was a 48, I wouldn't try a 3. I wouldn't try a 4. I wouldn't try any of those. It's going to be wasting my time. Okay, so that's that.